Good morning. Well, it's morning now. This is Mr. LaBeouf with a video geared towards seventh graders having to do with a topic which becomes very important moving forward into high school math, and that is the topic of exponents. Let's review what all middle school students learn about exponents first. Now, there is a collection of numbers known as the natural numbers. The capital N here stands for that. And the natural numbers, also known as the counting numbers, are simply 1, 2, 3, 4, 5, 6. Notice that these counting numbers or natural numbers do not include 0, and they do not include negative numbers. If we were to expand this set of natural numbers to include 0 and then all of the opposites of those numbers, then you'd have the integers. But for now, we're going to just restrict ourselves to the natural numbers. Lowercase n is a member of the natural numbers. This little symbol here means a member. So down here, this n is either 1, 2, 3, 4, 5, 6, 7, and so on. And x is a number being raised to the n power. And what that means, of course, is we multiply n x's together. For example, 4 to the third means 4 times 4 times 4, or 64. 3 to the fourth means 3 times 3 times 3 times 3, or 81. This is what we all learn probably around 5th grade about exponents. But we have to expand our understanding of exponents. The first thing we're going to consider is, what if the number being raised to a power is negative? In other words, from the previous board, the x is a negative number. Well, I want to start with this observation. These two numbers that we have represented here are different. They're different because of how we understand them, how we agree to see them, right? This one here we agree to see as the opposite of 2 to the fourth. This one, with the parentheses around the negative 2, we agree to see that as the number negative 2 raised to the fourth power. And the two results will be different. Here we raise 2 to the fourth power first and then take its opposite. That's how we agree to see this. So this one here becomes negative 16. Another way to think of it is the negative sign is not being raised to a power. It's only the 2 that's being raised to a power, and then we take the opposite of that result. 2 to the fourth is 16. This means the opposite of 16. This one, however, means we're going to multiply 4 negative 2's together because of the parentheses. That's what the parentheses do here. And of course, if you multiply 4 negative numbers together, you're going to get a positive number. So this one over here results in positive 16. The two results are different only because of the way we agree to see what's written. Another thing we can bring in here is the order of operations. Remember, please excuse my dear Aunt Sally. In the order of operations, we agree to evaluate exponents before we multiply or divide. The e comes before the m. So another way to think of this negative 2 to the fourth power is the opposite of something is the same as that number being multiplied by negative 1. So this is equivalent to negative 1 times 2 to the fourth. Well, the order of operations tells us to evaluate the 2 to the fourth first and then multiply by negative 1, which gives us that result of negative 16. What if we have the opposite of 2 to the third versus negative 2 raised to the third power? Well, in this case, the two results will be the same because the exponent is odd. We're still going to agree to see these the way we did with the last example, but it just so happens that because of the odd exponent, we get the same result. So we understand this as the opposite of 2 to the third. 2 to the third is 8. So this is the opposite of 8, or negative 8. When we evaluate negative 2 in parentheses to the third power, multiplying 3 negative 2's together, we also get negative 8. So the same result, but only because the exponent was odd. One last general observation about um, raising numbers to a power, particularly squaring a number. No matter what x is, no matter what real number x is, if you square x, you get a number greater than or equal to 0. If the x is 0, 0 squared is 0. But if x is anything else, you're going to get a positive number. Let's say x is 3. 3 squared is 9. But if x is negative 3, then you also get positive 9, because negative 3 times negative 3 is positive 9. A positive times a positive is positive. A negative times a negative is also positive. So you cannot get a negative number if you square a real number. You can only get something greater than or equal to 0. Now a little subtle point here is that let's say we have x squared, and then we're told that x is negative 3. Right? So we have this number to deal with, x squared, and we're told that x is negative 3. Now, if you think back to what we just said about how we agree to see things, here, this means that the x is being multiplied by itself. So when I was in school, I can remember teachers saying that you have to mentally insert a parentheses. If you're going to evaluate x squared and x is negative 3, you have to either think about it or write it like this, inserting the parentheses and realizing that what you're doing, what you need to do, is to multiply negative 3 by itself. So negative 3 squared, negative 3 times negative 3, or positive 9. If you just take the negative 3 and put it where the x is without the parentheses, as I said before, we agree to see this as the opposite of 3 squared, which would be negative 9. So mentally insert those parentheses when you're evaluating x squared. And something that comes directly from, that flows directly from this observation, that for any real number x, x squared is always greater than or equal to 0. Well, what if we put a minus sign in front of the x squared like this? Well, consistent with what we said before, we do not see this as negative x times negative x. We see this as the opposite of x times x, the opposite of x squared. If x squared is always greater than or equal to 0, then the opposite of x squared is always going to be less than or equal to 0. In other words, this here, with the minus sign in front of it, can never be positive, because the x squared itself is usually positive, or 0. The x squared itself can never be negative. So let's say it's positive, right? Put a minus sign in front of a positive number, you've got a negative number. You've got something less than or equal to 0. And of course, if the x is 0, the opposite of 0 is still 0. So please make sure that you understand this, everything that's here, because it's going to be very important going forward into high school math. Take care for now.